Hey guys, Scott Bryce from Performance. Today we're going to talk about a brand new exciting product for us. It's the Porsche Cayenne and the Volkswagen Touareg Extreme Angle CV joint. Much more angle, much more plunge, and a much stronger joint than you can get conventionally at the moment. We're going to tell a little bit about the joint, but before we do that, we're just going to talk a little bit about where we are, who we are, what we do, a bit about wheel travel, what a CV does and why it limits wheel travel, and why we developed the Touareg and the Cayenne and the Amarok CV joint for you guys. So first of all, we'll talk about who we are, Performance. So we're a manufacturer, we make race car components. We're based in Australia. We make race cars, we do these as a kit car. We manufacture components, differentials, transfer cases, steering racks, differentials, CV joints, axles, hubs, arms, chassis. We make everything in-house, and we'll just give you a quick walk around and look at some of the things. So here's some of the bits and pieces that we manufacture in-house: axles, CVs, shafts, bits and pieces, diff carriers, etc. We have a bunch of stuff on the shelf here that we're making for customers in the US for our race cars. So these are gearboxes and transfer cases for trophy trucks. We have Yamaha diffs that go on the back of the Yamaha race cars to increase the horsepower rating. We have a bunch of transfer case and gears down here that we're producing for motorsport. This is one of our typical CNC machines where we do all of our in-house machining, etc. We'll jump over to the milling machine and talk about some of the things we're doing with the Amarok joints. So today our machine's been busy making some prototypes for the Amarok while we're playing with the Cayennes, etc. in the US. The Amarok's an Australian product, very popular here. So this is one of our jigs we've been playing with the Amarok. We have some other CV joints over here, and while we're on the subject of CV joints, we just thought we'd show you these. They're just about to be shipped out to the US today, so we thought we'd just leave them out of the box and show you guys some of the extreme angle CVs and what we're doing with those in the US. Okay, so I just wanted to talk a little bit about axle length and CV angle, etc. And we'll run around and we'll have a look at our ultra narrow differential here and talk a little bit about why we developed this particular product for the market nearly 15 years ago. So this is one of our core products we've been manufacturing for 15 years. They come in all sorts of different sizes. We make the entire component here. It's all made in-house. And you can see the CV joint tucked right up inside. And we're going to explain today a little bit about why we do that and why the Predator and all of our race cars have these internal CV joints and extreme angle CVs. So the reason we try and tuck the axle right up, the CV right up into the differential, is to get a longer axle. A traditional CV joint, this is a Cayenne joint here, or an Amarok joint, they're very short and they've got a very small amount of angle, so you get a very small amount of wheel travel. When you make the differentials narrower, you put the CV joints inside and you make a much longer axle, and we'll talk about, there's an axle, that's out of one of our race cars, so you can see here how long these things are. If we compare the length of this axle to a little Amarok axle, you can see how much more length we get and how much more wheel travel we get. So imagine this thing moving up and down. You can see how we get 30 inches of wheel travel on the left and 30 inches on the right. So I'm holding the world record on wheel travel, which is really a nice thing to have. So trying to get longer axles is very important. But getting more angle is also difficult. So for, 30 odd years, race cars and Volkswagens and buggies have been running these 930 and 934 CVs, very similar to what the Cayenne and Touaregs are running. We did some research into how to make better differentials to get more wheel travel out of our kit cars by researching what they're doing in the side-by-side market. So we'll bring the camera and have a look at this. This is a traditional sort of Polaris, Can-Am, Yamaha type CV that's in the side of a diff. Now normally they would be hanging out the side of the diff, and that makes the diff a bit wide. Your axles are pretty short. We want everything inside the diff to make long axles. But these CV joints, when you look at the back of a Can-Am or a Polaris, they give a maximum of like 40 odd degrees, a massive angle. They get a lot more wheel travel and droop than a traditional Cayenne or Touareg CV. Very different technology. The 930, 934 CVs, the Cayenne CVs, and most rear suspension to CVs are limited to about 20 odd degrees of travel. These side-by-side CVs can run up to about 40 degrees. So we looked at the technology and we tried to consider how can we make that technology and put it into our race cars. So we took our existing diff design, which takes an off-the-shelf 934, and we manufactured a brand new carrier system. So let's bring the camera in and have a look at this. So we did away with the conventional Cayenne type, bolt-on type CV you find in Volkswagens and Porsches and sort of passenger cars. We did away with this joint and we created a similar joint to what's running in all the side-by-sides, but we made it way bigger than anything that's ever been made before. So this is our big joint. It's huge. It's a tiny differential, and look at the size of the joint we managed to squeeze in there. So there's a joint, goes right up inside, and we can get the CV joint right up here, and our axles are pretty much touching each other. Gives us the longest axles in the world, and it also gives the maximum amount of angle by using these joints that can move to 40 degrees. So your Cayenne joint moves to 22 degrees. These can move to 40. We recommend guys sticking about 35. So by getting a narrow diff, longer axles, we get more angle, more travel. By using these here, we get a lot more angle and more travel. So that's why we've done it. So what we want to do is talk about now is to why the Porsche has an issue and the Cayennes and Touaregs and what the problem is. So the problem that we've been asked to rectify with the guys in the US is the fact that they have a limited amount of wheel travel. And when we look at the Porsche system, we thought Land Cruisers had a very short axle. Well, that is unbelievable. That's one of the shortest axles that I've ever seen in any off-road vehicle or SUV type vehicle. Incredibly short, limited wheel travel. And I'm not too sure why, but unfortunately, you Touareg owners and Cayenne owners, they've used like a CV that would normally be on the rear of a car in the front of your Touaregs. They've used the same joint front and rear. And these joints are limited to about 22 degrees of angle. Every time someone puts a lift kit on the front of a Porsche, bring the camera and we'll have a bit of a look at this, you can see here what happens is the axle starts to smash into the boot, it gets overextended, it damages all of the flange, and these tiny little CVs, they're very fragile, they've got very small cages, they just explode. You cannot push them past what they were designed to do. Porsche and Volkswagen and BMW, etc., they spend millions of dollars in CAD designs, etc., to make these things go as far up and down as they possibly can based on the technology that the car comes with. When the owners of the cars try to exceed that, they just exceed everything in the car. The ball joints, the CV joints, the boots, the axles hit the boots, the plunge runs out, the CV gets stressed, and then they start to blow up. Everyone's telling us that in the Porsches, etc., they get clicking noises when they do about a 1-inch lift, they explode their CVs if they do a 2-inch lift. So we're really trying to fix that. Another issue with the Cayenne and the Touareg CVs is these little tiny boots. I mean, look at the size of this thing. There's the boots that we run in our trophy trucks, etc. It allows the axles to move a much larger amount, gets a lot more cooling in there. They're made of a different material. We use a high temperature silicon boot, which is much more pliable. These things, they belong in go-karts or little cars. So I don't understand how they ended up on a highly expensive vehicle, but that's what we're with, so that's what we're working with. So the guys at Dirt Pig in the USA, they've asked us, can we look at the existing CVs that we make for our differentials and the ones that we make for our hubs, etc. Can we somehow use this technology and make a CV joint that bolts up to a Cayenne or Touareg flange? So we have the Amarok and the Cayenne and the Touareg bits and pieces here. We've developed this one. They're being tested over in the US as we speak for the Cayenne and Touareg. Let's just bring the camera in and have a little bit of a look at the joint here. So this is the extreme angle joint for the Touareg and the Cayenne. And we've got a slightly smaller version, just a slightly smaller different size for the Amarok, which we're working on right now. So we're just making some prototypes for those guys. And I'll give you a bit of a look as to some of the differences, and I'm going to do a photo presentation, but let's get the camera in here and have a look at the size difference between some of the components. If you look, if I can put that down on the bench there, and we bring the camera in, look at the thickness of this cage versus the thickness of our cages. You can clearly see why these things are fragile and these things are super strong. 20 degrees, 40 degrees. Paper thin cage, super thick cage. It's a bigger spline, bigger cage, bigger star, bigger balls, bigger joint, much more travel. And of course we can get up to 100 millimeters of plunge. So we have 4 inches of plunge, more angle, stronger joint, bigger balls. Everything about it is just bigger, stronger, better, and it gives the guys that are doing lift kits a lot more wheel travel, a lot more droop, a lot more ground clearance. Now what happened with that is, one more thing I wanted to talk about. This joint is something we haven't seen for quite some time. The joint that we've got from one of the aftermarket joints here, can you see this little circlip on the top here? Most joints aren't made like that anymore. And when you put the Amarok or the joint on the top of there, they're using this circlip to stop the joint from moving. It's one of the worst things that you can do in an engineering point is actually introduce a point of failure. But that little groove around there is a stress raiser, and it probably reduces the strength of that axle by about 75%. So it was really surprising to see that. If you look at the axles and components that we make, you'll see a little neck down here, this beautiful radius. It gets rid of the stress. There's no circlip grooves here. And then we have a little spacer that goes in here to space the components away from a shoulder. Choosing to make axles like this is something we haven't seen for 20 odd years, but it's somehow ended up on the Porsches and Touaregs. They have this stress raiser joint, so that is probably the weakest part of the entire axle, but they're not breaking at the moment, so they're just blowing up the CVs. I'm sure we can address them. If we start fixing the CVs, we might start seeing guys breaking the axles. So these are massive, they're monstrous. We have a few different options, so we'll just point the paper around so I know what we're talking about. Now, on the CVs themselves, we've been asking about price and how they're going to work and who's going to get them and how they buy them. We've got a few different resellers around the world. At the moment, Dirt Pig in the USA is probably going to be the main guys you want to go to get hold of these things. If you want to be a distributor, reseller of these things, just talk to us after the video. But we're going to have these things in a few different variations. Because we make motorsport parts, we don't make car parts, we don't make billet mirror mounts, we don't make subwoofers and spotlights and bolt-on junk. We make race car parts. These things are made using the same high-tech materials that you find on the Predator. So let's just have a quick walk around the Predator. I just want to show you the sort of stuff that we make so you understand when we talk about pricing what it is that you're buying. These things are anywhere from $200,000 to $400,000 race cars, depending on what people put in them. Trophy trucks around $1 million. We are manufacturing components for $500,000 vehicles and really high-end gear. It's all billet aluminium and chrome moly and case hardened, stress relieved, cryogenically treated, shot peened, really high-end stuff. And we make some of what we consider some of the best components in the world for motorsport. We do some really unusual things. We use really innovative technology. These extreme angle CV joints, custom-made axles, handmade parts, handmade hubs, all these things that we make in-house. And then when people ask us to make a joint for a Cayenne or a Touareg, we need to sort of evaluate what it is that joint needs to do. Is it going to experience the same sort of stresses that our race cars experience? These things are running 35-inch tyres, they do 130 miles an hour. They've got some high stresses, but do we really need the expensive Formula One type stuff in the Cayennes and Touaregs? So I just want to talk about the different stages of CVs that we'll probably offer in the future. So we have stage one, which is a case hardened super duper joint that we're using in our DIFF carriers, etc. And that would be our stage one joint, and that'll have a price tag of a motorsport component. Then we have a chrome moly component, which is a chrome moly version, again case hardened out of a different chrome moly material. And then we're going to offer the stage 3 version, which is cryogenically treated. So it's going to be almost twice as strong as the stage 2 joint, but it's cryo treated. So if you've got 600 plus horsepower, twin turbo V8s, 35-inch tyres, and you want to climb up Moab, you might need the stage 3 joint. And then the stage 4 Cayenne and Touareg joints, they're for the ultimate guys, the guys that want this sort of components, this sort of equipment. It is an EN36. It's the same material that Hollinger use in their Hollinger gearboxes. It's the same material we make all of our shafts from. All of this stuff that we make in-house is all the highest quality EN36 material that we can get, and we can make these joints out of EN36. The price tag of these things is based on motorsport components. They're not car parts, they're not made in China. If they were made in China out of crap material, they're paying $10 each for the joint, they put them on an axle, they put some boots on them, and you can probably get them for $300 or $400 an axle. We don't do that. We make race car parts, and I'm sorry, I've written on my sheet of paper here, my notes. If we start getting complaints about the price of our components, I'm sorry, you're just not our right customer. We make race car parts. If you want to put race car parts on your Porsche to solve your problem of blowing up these things and being stuck on the trail, this is the solution. But please don't complain about the price of the stuff that we make to fix the problem. If it's out of your league, take the lift kit out of your car, put it back to stock, and stop blowing up the CVs. If you want to fix the problem, This is the solution. You just need to talk to us and our resellers about which of these stages you want, how much horsepower you've got, what sort of driving you do, and then we can determine, do you want a stage 1, stage 2, stage 3, or stage 4, and the pricing will be reflective on that joint and what we're doing with that joint. So I hope that answers some of the questions on the joint itself. The question came up about arms. Obviously, once we put the prototype joint onto the car in the US, they got so much more wheel travel and so much more droop. They've never been able to do this before. All of a sudden, the ball joint on the outer ball joint on the lower arm bound up, so they couldn't get any more wheel travel because it wouldn't go down any further. Now they're asking us, can we make lower control arms? Of course we can. We can make arms with different sort of configurations, but we generally use Heim joints. And I just want to bring the camera over to the Predator here so you can have a look at this hub. So whenever we make something using Heim joints, spherical bearings, whatever you want to call the thing, we always try to put the Heim joint so that it's sitting vertical and the bolts so they're sitting horizontal. We have the bolts in double shear. Running these things in single shear is very dangerous. And that's the correct way to run a joint. Now we'll just run back to the bench. I'm just going to show you a little bit about why we consider it's necessary to run the joint that way. So trophy trucks, etc., they run these things in a slightly different configuration. Typical high misalignment space are these sorts of spherical bearings. They're designed to operate a particular way. They're designed to be loaded like this. When you load a spherical bearing in this plane, it might have a 100-ton rating down on the top here. If you tip the bearing over, now, before I say this, I'm probably going to offend 90% of the manufacturers in America. And I don't want to come across as a smart-ass. It's just a fact. This is an engineering fact. When you run these joints with the load this way, it might be a 10-ton rated joint. When you run the joint this way, which we see a lot, it's a 1-ton rated joint. And you start putting this in motorsport applications, pounding your car up and down on rocks and trails and etc. They'll flog out 10 times faster this way than this way. If you put the joint this way, you can use a joint 1/10 the weight. If you look at the size of the joints on our Predator here, this whole car is made to be as light as possible, but we've done that by using the technology that allows us to use a joint much smaller than everyone else. If you wanted to run it this way, you'd have to run a trophy truck joint. They're about 3 inches in diameter. They've got a 2-inch hole in the middle to be able to take the loads that we can do. So if we're going to be developing arms for the Cayennes and Touaregs, we'll be running a joint where possible this way, or we'll generate a spherical ball joint where the ball joint is like where they have a 180-degree contact patch. So watch out for the arms that we're working with. Bryce and Richards we're talking to Dirt Pig, we're talking to the guys at Berg, we're talking to the guys, Mike at the other guy, Mike Eng. So there's a lot of interest in us helping you guys solve the problems that you've got with these vehicles, but you just have to bear with us that when we make race car parts, they are race car parts. And if you're going to put race car parts on your vehicles, we just have to work with us, and we'll do the best we can to keep the cost down. But if you want a real solution, long travel kits with longer axles, longer arms, more travel, bigger ball joints, Heim joints, etc., we can do it, but they will be motorsport type components, and it's only going to suit a certain type of customer. So keep an eye out for which way we run these. And again, I don't want to offend people who do it that way. There are reasons people do it to get more steering out of the vehicles. Four-wheel drive vehicles typically only need 30 degrees of steering to get really, really highly manoeuvrable vehicles. Running 30-degree CVs, which is what we're running on the new extreme angle joint, 30 degrees of droop and 30 degrees of steering provides a 45-degree included angle at the joint. Now the Cayenne and Touareg have a 46-degree CV, like most cars. So we're comfortable that running this joint at 30 degrees, we're going to get 30 degrees of steering left, 30 degrees of steering right, without binding and damaging the outer CV, because these things are limited as well. So we have to make sure you guys follow our instructions when you're fitting these things on. We may need to put steering stops in the racks to reduce some of the steering that the Cayennes and the Touaregs have right now. If you want to push the suspension to the limit, we may need to help you guys limit a couple of things to get the limit out of it. If you don't want to push them as far, and you just want to push them to that 26, 27 degrees, we can bolt them straight on without doing any mods, but you won't get the wheel travel. So it's incredibly exciting to be able to help these guys out with this product. We don't go looking for products like this. We don't go looking for markets, say, how can we make money out of this? the markets come to us, they see the things we're already making, they see the cars that we make, they see the technology that we've come up with, they see the wheel travel that we create, and they've said, help us, we've got a serious problem. And that's how this has come about. So I hope that explains who we are, where we came from, why we're doing this, how we're trying to help you guys, and in the future, once these things are all sorted out, we've stopped all the clicking and exploding CVs, then we want to work on these arms. We've come up with a dummy the other day, get you guys really much longer travel arms, double the length of the travel of your shock, really get some serious wheel travel out of it. Burson Richards has offered to help us out with a lot of suspension geometries, so if we do start lifting the cars extreme angles, we'll be able to make sure we don't have a change to the Ackerman, the kingpin inclination, the caster, the camber, the bump-induced camber, all the things that are important in race cars and Porsches and Touaregs, etc. We need to make sure we don't mess with that geometry. So if we can get the arms correct and we get all the pivot points in the right place, we'll have an awesome solution. So bear with us. We've got guys testing these things. Once we've got stage 1, 2, 3 and 4, we know how long they last, how strong they are, and then we'll be able to give you guys final pricing once we know what you guys actually need. So tell us what your horsepower is, talk to the guys at Dirt Pig, and keep an eye on the Facebook page and our website, because we're going to put more information about the joints up there. So guys, thanks very much, and hope we can help in the future, and welcome. Thank you.